Well, we'll get started. So, hello everyone. I'm Marie Sablier. I'm the coordinator of the online webinars for sustainable energy for the Francophonie pour le développement durable. So today's webinar is organized by the Global Sustainable Electrical Partnership. It deals with electric mobility, a concern of the G7 and many French-speaking countries as well as other countries. But before we get started, a few housekeeping rules. Next slide, please. So, the webinar is broadcast with simultaneous interpretation in both French and English. Choose the channel of your chosen language and you'll be able to listen in this language without needing to change afterwards. If you want to follow the English slides, you can download them from the link that will be supplied in the chat in a few moments. So to improve the quality of the broadcast, we recommend that you turn off all your unused apps on your phone, computer, or tablet. If you lose sound or connection, you need to leave the webinar and reconnect. To ask questions, write them in the chat at any time during the webinar. We will answer them at the end and we'll deal with them afterward if we can't answer them live. This webinar is recorded. Both for the French and English slides will be available online in a few days on our websites. These are public webinar available free at any time, so feel free to share them with your colleagues. So today, we will hear a few words of introduction from the representatives of IFDD, GSEP, and ONEE. Then we will hear our keynote speakers, and we will finish with a Q&A. The webinar will end with a survey. So, Mr. Dabo, you're a specialist of programs at the IFDD, so I'd like to invite you to welcome everyone. So hello, everyone. So it's a pleasure for me to welcome you at this new Francophone meeting of sustainable energy. And as you know, the Institut de Francophonie pour le développement durable is an organization working with French-speaking countries. This webinar is done in partnership with the GSEP and the National Office of Electricity and Drinking Water of Morocco. And I'd like to introduce to you the directors of these two institutions that shows the great cooperation we have with the GSEP. The GSEP has as its role to implement sustainable electricity in Francophone countries. And these are part of countries and that strengthen the management and the broadcast of sustainable energy knowledge among Francophone countries. To date, we have 40 webinars on sustainable energy that were organized. Some are also available on circular economy and the environment. Today, we are dealing with electric mobility, notably the feasibility of electric transportation projects in cities in the context of energy transition and sustainable development. So I'd like to thank our speakers today, Mr. Ali Lamin Feshtali from Morocco, Naim Farouki from the World Partnership, Global Sustainable Electrical Partnership, and Luis Calzado, Senior Advisor for GSEP. So on these words, I want to thank you who have chosen today, once again, to increase your knowledge in sustainable energy, and I hope you'll have a great webinar. So thank you, Ibrahima. Now I'd like to invite the Director General of GSEP. So hello, today I'm very pleased to be with you for this session dealing on a very important subject when we are thinking about the fight against climate change, the electrification of transportation. So I am the director of the Global Sustainable Electrical Partnership. So this partnership is an alliance of CEOs of the largest electrical utilities in the world. Our actions promote clean and renewable electricity, energy efficiency, and electrification as a way of meeting the global objectives in terms of development and climate change mitigation. In other words, the struggle against climate change and decarbonation starts through greater electrification. For the CEOs in the Global Sustainable Electric Partnership, our objectives are electrification that are beneficial for all. So we need to grow the economy at the same time. We need to increase social progress so that at the end, no one in society will be left out. To do this, we cannot work alone. We have to break down the silos, encourage partnerships and cooperation so that together we'll be able to meet the greenhouse gas objectives that we have by 2050. To meet these objectives, and this is at the heart of our presentation today, the transportation sector is extremely important. It's one of the largest source of greenhouse gases on the planet, without mentioning the impact on health that this creates. I'm thinking of fine particles and other products released into the environment. But it's a field that where we have the technologies required to transition towards cleaner transportation. On my behalf and that of our group, thank you for your interest in this session, and I hope you will be inspired in working towards energy transition. Thank you, and I hope we'll meet in person in the future. Thank you very much, Mr. Duval. So to finish this roundtable, I'd like to invite the Director of Cooperation of Morocco to share a few words. Mr. Langtari, it's all yours. Hello. It's a pleasure to be with you in this very important webinar. I will be brief. In a nutshell, I want to tell you that ONEE is a member of GSEP, and we've been members very recently now, and we are chairing the GSEP for the near future. As Mr. Duval mentioned, GSEP is an alliance committed to lead the transformation of energy utilities towards sustainable energy by reducing carbon emissions and to head towards a zero carbon economy. As the chair of this model, and it's a historical presence because it's the first time that an Arabic-speaking African country is the chair of this alliance, our objectives are first and foremost to work not only to contribute to move forward the mission of GSEP, but also to bring to bear the weight of Africa. And this is why it's an extremely important theme for Africa. It is dealt with because, as we'll see, Africa has not yet really started down the way of electrification of its vehicle fleet, but it's in our intention, and the presentations will illustrate this. As was mentioned by Mr. Duval, the transportation-based emissions are an important source of CO2, as well as being very noisy. Climate change is a reality, and transportation is an important cause of this reality, and electric cars have an essential role to play in energy transition. I believe it will be demonstrated through the presentations we will have today, and I hope you will have a great meeting and great presentations. Thank you, everyone. Thank you very much, Mr. Lagtari. Next slide, please. So here we are. The table is set with these introductions we've just heard. So sustainable mobility is at the heart of sustainable development, and it is very much considered for climate change. This being said, before going into the electrification of mass transit, feasibility studies and the implementation of pilot projects are certainly required. And this is what we'll be discussing today. So what regulatory and financial aspects must be taken into account in this electrification of transportation? So ONEE in Morocco has worked on this. And what are the conditions for success? What are the learnings from the GCEP's processes? These are a few of the questions that we will deal with today. To respond, we will be listening to three experts involved in the GCEP's work. First, Mr. Ali Emanin Feshtali is head of the marketing division at the ONEE in Morocco. He is currently in charge of electric mobility projects. He has worked in electric system planning and also in energy efficiency. So today, Ali will talk about the work done in Morocco to develop a national plan of electric mobility. Then we will listen to Mr. Naim Farouki, who's an expert in transportation for GCEP. His expertise is broad. It goes from the technology feasibility study to the development of projects and decarbonation. He has worked on projects in Canada, the US, Peru, Ivory Coast, and elsewhere. So today, Naim will talk about the aspects to take into account to succeed electric mobility pilot projects. And finally, Mr. Luis Calzado is the senior coordinator for projects for GCEP, specialized in electricity and implementing of renewable energy pilot projects throughout the world. Today, Louis will show us how the Naim's recommendations resulted very concretely in electric bus projects in Lima, Peru. Ali, you have the floor to tell us what is going on in Morocco. So, hello everyone. Thank you very much for this invitation. I want to thank you for giving us the opportunity to explain our vision and project. And I'm going to talk about our study to develop and implement an electric mobility project in Morocco. Next slide. So first, I would like to give you the context. It affects all countries. So electric mobility needs to satisfy environmental objectives, energy efficiency objectives, and also a reduction of energy dependency. So in all countries, we have transportation systems that consume a lot of energy, but they also can be polluting. So in this case, Morocco wanted to orient itself towards electric buses that are more respectful for the environment as a sustainable and efficient alternative. So Morocco has demonstrated its commitment in favor of electric mobility through some initiatives. There are initiatives concerning recharge stations. We have more than 100 recharge stations. They are implemented throughout the main highway, and we have also tax incentives and an exemption of import and luxury taxes for electric vehicles. And the government wants to lead by example by electrifying all fleets of public vehicles. So, to implement this framework favorable for electric vehicles, we need to develop a national policy for electric mobility that needs to be oriented towards a shared vision, an integrated vision with all actors in mobility from all sectors. It has to represent also awareness raising and anticipate the requirements in terms of infrastructure and regulatory frameworks. So the ONEE, as a key actor of energy transition in Morocco, we are a reference in the electric market. We need to turn electric mobility an important part of our strategy as to guarantee the equivalence between supply and demand, and to accompany in the development of electric mobility essentially through the development of infrastructure, both in terms of production or generation and distribution. So this is where the ONEE has decided to start a study to develop a national plan on electric mobility. Next slide, please. So this study has as its objective to develop a roadmap that will be available to all actors in electric mobility. It has to plan the implementation and develop electric mobility. Essentially, it has regulatory aspects in terms of rate setting and so on. It will also deal with the subsidy aspect and certification, and it will try to coordinate all the initiatives by all the stakeholders in terms of infrastructure development to maximize accessibility and interoperability of associated services. And among the objectives, it's important for ONEE to accompany in the development of electric mobility and to evaluate the impact on the national grid and on demand for electricity and the consequences on the requirements in increasing generation capacity and updating distribution networks. So first, we have to see what the state of affairs is on electric mobility in Morocco. The second phase is to do an analysis of international experience to see where are the successes and failures, and third, to make a proposal of a plan for Morocco. So these are the major steps. Next slide, please. So in this diagnosis, first we need to have a diagnosis of the existing vehicles in Morocco, and we have to look at the available electrical vehicles and the recharge stations. And second, we'll have to identify the different stakeholders of mobility. So in the first part, we have 95% of vehicles burn fossil fuels currently. So we'll have to analyze the constitution of the existing fleet. I see how these vehicles are used based on different criteria, type of trips and climate conditions and so on. And also, we'll have to evaluate the consumption and emissions of this fleet. So the second part is the diagnosis of the electric vehicle fleet today. We have about 2,300 clean vehicles, 300 electric, 2,000 hybrid. So that's less than 1% of the total. We have about 4 million vehicles in Morocco. 70% are for private use, and 2.8 million vehicles. So for that portion, we need to ask, what are the vehicles on the roads? What are the existing charging stations, and so on? And we also anticipate to do a survey to identify the perception of electric vehicles in the population. And always when we look at the situation, we need to do a diagnosis on the available technologies. Is it hybrid, rechargeable hybrid, hydrogen vehicle? So we need to evaluate the trends and outlooks of each technology. Next slide, please. So in this second part, in the situation, we need to do a diagnosis of what's available in terms of electric mobility in the market. So we need to study the current available electrical vehicles and also the charging stations that are available. And we need to analyze the expectations of the different stakeholders in electric mobility. Next slide. So in this portion, we need to identify the initiatives from the government on electric mobility. So charging stations by all the stakeholders in energy, strategic partnerships, and also we need to analyze the existing regulatory framework in terms of existing policies and strategies, in terms of existing standards of rate setting and marketing, of recharging possibilities, and also of existing subsidies and aid programs. So, always still in this portion, we need to identify or to do a SWOT analysis to identify the strengths, weaknesses, opportunities, and threats. For example, the weakness would be the cost of EVs. They're relatively expensive. The strengths, it would be the involvement of the state, of the government, and the threats might be, for example, the increase of raw material, for example, of lithium and rare earths. So in the second part of our major phases, we will analyze the international projects in the same vein. So we'll have to do a selection of countries that have relevant experience in this sector, that have made progress, and will identify the successes in electric mobility in those countries and also the failures. So the main criteria or the benchmarks will first be there needs to be a medium to long-term electrification objective. There need to be experiments that have been done, and electric mobility needs to be and the regulatory and legislative framework. So we need to, through this benchmarking, identify the factors for success for electric mobility and to see what are the benefits of electric technology. So the priming of the market is extremely important. To prime the market, we need a minimum of recharge stations. There needs to be a minimum of incentives for the acquisition of vehicles. So it will be based, of course, on the SWOT analysis that was done and also on the keys to success that have been identified that come from international experience, and essentially in terms of planning the implementation of a recharge station network. So we'll need to recommend some programs and subsidies to promote this mobility project, to also offer charging rates that are low enough to be an incentive, and also we will need to propose a promotion plan for electric mobility at the national level to encourage the stakeholders and also for users.
La prochaine diapo, s'il vous plaît. Next slide. So also we are hearing through the different analysis and the expectations of the different partakers, concessions, users as well, car manufacturers, to evaluate the infrastructures in place to recharge. We have to propose these different scenarios. That are on the intervention of the state and subsidies. This scenario will also be on the offer of the world market, of dealers and car manufacturers, and the offer of the manufacturers and marketers of charging stations, and the perception of electric vehicles among the users. The next slide, please. This study, the impacts of integration of electric vehicles in Morocco. So there is already the impact on the electrical system, which is really important to anticipate the evolution of it, and the integration of the electric vehicles in the system. Study the impact of the charging national load on the capacity of electrical transmissions and distribution work, and to study the different possibilities of a combination of vehicle charging. There's also the study of the different possibilities of combination of vehicle charging electrical with energy production, starting from sources of energy that are renewable, and to study as well the reserves, to see the other impacts, the financial impacts, environmental impacts, and socioeconomic impacts. Next slide, please. So the proposal for an adapted regulatory framework that would be adapted to promote and develop and strengthen the possibilities, the devices for supervising electric mobility, standards of the installations of charging stations, charge control, roaming performance, platforms, etc. Also, the training of the personnel for the maintenance of the network, implementation of R&D, strategic and industrial integration potential, and to put in place the actors of these electrical mobility for the creation of a governance bodies, the definition of the different actors of mobility, roles, and responsibilities. The status of the marketer or the charging. Right now, today, besides the distribution of energy, for example, a station cannot sell the kilowatt hour to the user, who will have to provide a status to authorize the resale of electricity, and have to provide for structures of pricing dedicated to recharging of electrical vehicles. There'll be an incentive, essentially, during the first phase. Next slide, please. And so here we see the proposal for a reinforcement plan charging infrastructures, medium and long term, strategic partnerships, the important ingredients to have a network to promote this project. We'll have to study what are the possibilities of the strategies, different actors between dealerships, the builders of the stations, essentially propose adapting the structures in place, the charging stations, the charging power, the ratio of number of electric vehicles per charging stations, interoperability, and the services associated to the recharge, payments, for example, and other services, location of charging stations, important positions, possibly petrol stations, public and private car parks, residential areas, detached houses. They're also the control of the charging station, smart charging, as we call it, that the network will not be overloaded. The research will permit this to modulate the power of recharge, and then the model, the organizational commercial model of public charging stations for the public and private sectors, and have associated regulatory framework, tariff recommendations, eligibility of actors for real sale of charging, and etc. Next slide, please. And so here we see the last plan. Investments will involve investment plans and financing mechanisms. That there be incentives, public investments and/or state, private investments that will include the different grants and donations to be able to start this market, with proposals for mechanisms of funding that involve funders. Next slide, please. And so the goal, the most important, is the National Master Plan Roadmap that will cover all the steps that I've just presented to you all. In addition to this master plan, there will be a synthetic roadmap that we must promote to the parties and stakeholders. It is a plan and a roadmap that must be a national plan, and the idea being to create the interest for all the people involved for this national plan. What is really important in this plan, because it's the starting point, this plan must also define in a clear way all the roles and responsibilities of every stakeholder in the successful launch of this program. the factors of success keys to, first of all, to successfully start the successful seed phase, minimal interoperable charging station network infrastructure, sound incentive mechanisms, grants and funding, obviously to provide for the fees, also see the international experiences, a plan of communication to inform and sensitize all the stakeholders. And also it's a plan that must be a national vocational plan, the commitment of all the stakeholders to bring them around the same project. And finally, to the electric mobility, to obtain a better information from these renewable sources. And for the different actors, users, and the producers who will authorize the buying of electric energy at a fair price. Next slide, please. So I think this is a recall of the main keys. We could, the starting phase. I'm sorry, inaudible for the interpreter. There seems to be a technical glitch. One moment, please. A plan of communications, international experience. Thank you very much for your attention. I think it's the end of the presentation. Thank you for your attention. Thank you very much. Thank you, Wadi. And so we continue now with Naim. So Naim, what are the aspects that take into consideration to succeed the projects of electric mobility?
Pilot for a public transit opportunity. Next slide. Yeah, so electric buses are being deployed all over the world in different regions with opportunities of different types, sizes, and battery and charging methods. And, all of these sort of decisions have moved forward with business plans as well as feasibility studies. So it's really important to build that upfront feasibility. And what I'm going to talk today about are some of the challenges and opportunities. So next slide. So in this one, from a technological standpoint, the infrastructure planning, the high voltage power distribution, the grid demand management, you need to understand how much electricity is available that's coming to your depot or garage, the range limitations around the vehicle. Some buses run for 13, 15 hours a day. You need to understand how much power and range the electric bus will have. Local skill set for fleet and infrastructure maintenance. These are high voltage systems. There are different type of maintenance that needs to be done. So understanding the technical capabilities of your maintenance staff is really important. Next is the financial. And in the financial, you want to understand, what does it mean in terms of higher vehicle costs up front, in terms of capital, and then the savings in the OpEx side of the deal. So capital investment for supporting infrastructure is also needed to be considered around buying all these chargers and the risk of unproven technology and life cycle cost savings. So the reason they say unproven is because we don't have electric buses that have run 12 to 18 years today. So it's important that a thorough due diligence be done on the total cost of ownership to understand that. And that's why doing feasibility studies and pilots gives you that comfort before you commit 100% of your fleet. Institutional, lack of favorable policies, grants, or incentives, land acquisitions for charging infrastructure. So on institutional side, you need to understand that, government programs, incentives are really important, and partnerships. We've seen a lot of great deployments all over the world around using utilities and government incentives to get public transit to go electric. Moving on to the next slide. So how to overcome barriers using a pilot? Uh, So first, there are barriers in the facility, there are challenges in the infrastructure, fleet, and people. So I'll talk about each one at a time. I can explain how you can overcome them. So next slide. So in terms of fleet vehicle specific, electric buses come with many features which can impact range of the vehicle. Battery size, many OEMs allow for various battery size to be installed on bus. So you can get as little as 76 kilowatt hours to as big as 660 kilowatt hours for a traditional 40-foot or 12-meter bus. So it's important that you figure out what size do you need. And the other thing is the more battery you put on, the heavier the bus becomes and the less passengers you can carry. So there are road limitations on how heavy vehicles can be on the road. So you need to consider that. Some OEMs allow for diesel auxiliary heaters for colder climate to minimize impact on range. If you're in a colder climate and you're concerned about range, putting that auxiliary diesel heater is a better solution. You're not at 100% zero emission tailpipe. You're at like 98%, but it's a lot better than just running a diesel bus. And one of the things that we recommend is input from simulation outcomes can influence the vehicle specification. One of the tools I use is a zero emission sim, and what it does is it gives you all that information and using a digital twin of the vehicle and your terrain and operating requirement. And that helps build a more robust specification. Next slide. So on infrastructure and charging considerations, you have to think about upgrades to the infrastructure to site. When you're consolidating 50, 100, 200 electric buses on a site, you start talking about 5 megawatts to 20 megawatts of power needed over the course of 24 hours. So that really, you have to have those conversations with the utility and understand what they can provide you. Then you have to think about transformer installation. You might need multiple transformers, a switchgear, even build up a little substation on site. Charger size and kilowatt hour speed and charger location are all important. How you lay them out, are you going to use pantograph? Are you going to use plug-in? All those considerations need to be made. And with those considerations, you can build a better pilot and a better deployment overall. Some clients like using pantograph, some like using plug-in at the depot. So just think about that. So now talking about the facility charging impact, next slide. The garage layout, bus parking lane with width to accommodate charging stations. That's important. When you're parking these buses and you're not historically used to those plugins, they do take up space and you can lose an entire lane if you have a 5 or 10 lane parking. Next slide. So that's one thing. Roof and overhead door clearance for e-bus, height, access to roof mounted batteries. So that's another consideration. If you're running an automatic car wash for the bus to go under, look at the top railing. Is it the right height? Will it work? And then chargers one-to-one to electric bus. We've heard right now with many clients that one-to-one is the right ratio. So you're going to have one dispenser for every electric vehicle. And the reason why we do that is just to make sure that there's availability. And secondly, you can put some of these dispensers in the maintenance area so that when vehicles are after they're repaired, you don't have to drive them to the storage area. You can just click them in and charge them. On-site power infrastructure, upgrade on-site high voltage transformers, distribution of utilities to site, ducting of electrical cables and facility charging stations. So we recommend building conduits where you're running this high voltage power through and it's enclosed, so it's a little bit safer. overall depot space reduction due to charging electric bus equipment. So you have to think about the fact that you might want to put energy storage systems, some batteries there that will also reduce their real estate, right? You might want to do co-generation with some solar PVC on site. So these are all ways that you can innovatively deploy a pilot and a successful transition. So on the people side, this is the last of the four themes that I'm going to talk about today. On the people side, one of the things you need to understand, next slide, please, is that there is advantages and disadvantages around maintenance. So what I'm going to do is I'm going to highlight some of the advantages and some of the disadvantages. So annual brake maintenance expected to be lower. Regenerative brake extends life by 3 to 4 times. So you don't have to worry about those brake pads because of regenerative braking. You're not applying the brake and eroding that material. Direct drive traction motor has less mechanical and wearing components compared to diesel engine. So you don't have the filter job, you don't have the oil changes anymore. Bulk fluids, engine transmission will not require reduced environmental impact and spill risk. So, staff don't have to worry with that. No diesel fuel, reducing spill risk and fuel expense. Diesel after treatment removes maintenance of diesel particulate filters, exhaust gas reduction, EGR, and other systems. So everyone's familiar with Euro 6, Euro 7. Those come with a lot of after treatment systems and requirements that create problems. The electric bus does not, so it's much easier and cleaner to run. Next slide. So in terms of disadvantages of electric bus, it's an unproven total life cycle cost. Like I mentioned earlier, one needs to consider that and think about what's going on. And the way to do that is to share knowledge with other agencies who are doing this, as well as building your pilot and taking that information and extrapolating it out to the full bus life cycle. It's a more complex electrical system, power electronics, battery thermal management system. So you just need to make sure that your staff are trained and are comfortable working around this. Mechanics and staff training required for high voltage systems needs time to become familiar and troubleshooting, right? So there's a lot of troubleshooting that will come from a new technology. So just make sure maintenance staff are trained and you're working with the respective bus OEM to provide support. Additional cost of PPE and specialized static-free tools. So think about simple things like wrenches, screwdrivers. All those have to become static-free. They have to wear a different level of PPE. And then the last thing is the diesel auxiliary heater will incur higher HVAC maintenance costs as trade-off of less impact on operating rate. So that you will have to have some diesel on site to fuel these auxiliary heaters. And there's another maintenance element. So moving on to the next slide. So one of the things we tell people who are looking at building pilots and transitioning is key performance indicators. So what are KPIs? So KPIs are quantifiable standardized measure of evaluating the success of a technology, policy, or implementation, right? So you establish some KPIs. So why are KPIs important? Track eBus implementation through pilot program, validate OEM performance specifications, i.e. energy consumption, compare electric bus versus diesel bus technology, track maintenance policy and operation, and implement a feedback loop with KPIs to improve performance. KPIs are really important because if you don't set them up at the onset, you really don't know if your pilot is successful or this deployment will be successful. So, spending some time upfront, doing a stakeholder workshop and understanding that information is really important to give yourself more comfort. Next slide. So a dashboard can provide a quick summary of how an electric bus platform works against any key evaluation development. So this one I'm showing you is like system compatibility. This is bus 1, 2, and the baseline is diesel. You can see the model 1 meets it, model 2 is not. Vehicle performance is okay. Model 2 is very good, and baseline is very good, and so on. So you're getting an idea of how a dashboard can help. There are a lot of metrics that can be tracked as part of the dashboard. You can track kilowatt hours per kilometer or mile driven. This gives you the energy efficiency. You can track mean distance between failure, how often this vehicle breaks down. You can track defects found in. So defects found in is when the driver does the pre-trip and post-trip inspections, if they found any defects during that stage. So there's multiple ways that you can build better comfort around this technology deployment. Next slide. So in terms of pilot performance, pilot tracking, and testing, general, important to establish a pilot structure, create a database for KPIs for monitoring, use data hubs for collecting data, establish processes for collection. So in the Lima electric bus pilot, which Louise will expand on, we installed a data hub, established Wi-Fi and survey for customer feedback, quarterly vehicle health monitoring, and a replicability report, which would provide a robust conclusion on that work. Next slide. So what is a data hub? So a data hub is basically a place where you can collect third-party telematics information. Two vendors that I selected was Veracity and Tessium. So Veracity collect vehicle performance and energy consumption data, monitors real-time vehicle location and performance, and gives you greenhouse gas emissions of the electric. So you can sort of show the savings off the diesel. Tessium collects the vehicle performance, energy consumption, same thing, but it can isolate the subsystems for energy consumption, such as HVAC. So it gives you an idea of installing these independent data loggers. You can rest assured know where your vehicle is at any time, the state of charge within that vehicle, and how it's performing relative to your network. Next slide. So pilot testing, one of the recommendations is purchase a limited number of electric buses. Ensure lessons are incorporated into the larger purchase. So you might learn that this product doesn't work in your geography, that you wish that you had put in more fire thermal management systems inside the vehicle, or you should have put Wi-Fi or USB connections for charging. So that pilot gives you an idea of all that. A pilot allows for vehicle specification and simulation assumptions to be verified against real-world data of vehicle performance and range. So also with a pilot, you can confirm if the simulated range was correct and how it would perform in the real world using that data, and then you can extrapolate and build for bigger deployments. Developing key performance indicators for pilots to ensure a strong data capture process performance evaluation. So before entering a pilot, I recommend always to build your KPIs, because if you're building KPIs as the pilot is going on, it might lead to bias. So I always say get the KPIs out of the way before the pilot starts. That way it's not biased. The Lima electric bus pilot is on Route 201, and I think Louise will talk more about that. Next slide. So some of the lessons learned from that operation is during a pilot, no BYD manufacturing in Peru. Spare parts would be delivered from Panama. BYD to provide servicing and maintenance for 2-year pilot. Need to train local mechanics. Operator familiarity, high torque electric motor difference and acceleration, regenerative braking, BYD to provide driver training, emergency response protocol. So we had the opportunity to actually do driver training in Lima, where we showed various drivers how to drive the vehicle for them to get familiar with the acceleration of an electric drivetrain versus an internal combustion engine. Next slide. So in terms of capacity for charging, existing electrical infrastructure upgrades, overnight off-peak charging to reduce grid impact and cost. Electrical troubleshooting, local staff need to develop knowledge of electrical bus systems. Reduced maintenance may initially be offset by troubleshooting time. So it's important to understand, if you don't give your mechanics some training, they will have concerns of when they're going near the vehicles for troubleshooting. So we did do that with a lot of maintenance staff in Lima. We showed them how to shut it off, how to do lockout and tagout procedure. So it's really important that those things be considered. And road conditions, electric bus clearance, high floor design, avoid routes with potholes, gravel, or uneven pavement. Increased battery weight can also impact road surface. So these are examples, right? So you cannot spec a vehicle in one geography and just plop it into another. You really need to understand the local conditions that are driving that geography and what vehicle can meet its operating requirements. So thank you. Next slide. Anyone would like to contact me, there's my Gmail as well as my LinkedIn profile.
Merci beaucoup, Naïm.
Thank you very much, Naeem. The next question of discussion. And so, Louis, we'll continue with you now to discuss the project of electric buses in Peru.
Thank you very much. So I want to thank the GSEP to give me the opportunity to present the Lima project. And as you will see, we followed Naeem's recommendations to develop this pilot project. So the objectives was to help improve, mainly environmentalists. So in other words, we want to decrease or improve the air quality in Lima and to give access to electric mobility in urban transit. And to do that, we developed a strategy to maintain the first electric bus in Lima in order to help the city to develop this pilot project and extend it in the future. So how did we proceed to be able to develop this project? We did two studies. The first was a pre-feasibility study. Its objective was to analysis urban transit in Lima and to look at the regulations of urban transit at the governmental and municipal levels. To do that, we worked with different partners. The first partner was the Department of Energy, the second, the Environmental Department, Transportation Department, as well as the organization in charge of urban transit in Lima. Once we did all these feasibility studies, we were able to implement a development plan for the pilot project. So this shows who the stakeholders were in the project. So in the project management and the financing, it was managed by the GSEP and the two companies that developed the project, NLX and Hydro-Quebec, notably. On the local side, with different local institutions, the first was the Energy Department, Transportation Department, the Environmental Department, and the local transit authority, as well as universities and local facilitators to allow the bus to travel throughout the city. Now, the technology partners, for the bus, we chose BYD to build a customized bus. In terms of the data hub and data collection, we used the Vericity system. Now, for support, consultation, and data analysis, for the pre-feasibility study, we used the services of Tariff, and for the feasibility study, design and bus design, as well as for the pilot monitoring, we used WSP. As mentioned, after developing the pre-feasibility study, we identified to understand the routes in Lima, we decided to simulate 8 routes served by buses in Lima. We used simulation systems, in other words, by Bolt. These systems allowed us to simulate these routes, to simulate to see what buses were available in the market and taking into account the various parameters, the size of battery required, the number of passengers that a conventional bus in Lima can house, as well as the parasitic load. In other words, the consumption for HVAC, Wi-Fi, as well as air conditioning, the weight of the bus, the topography of each of these simulated routes, and we wanted to understand if the charging infrastructure located in the garages would be able to supply the buses with the required charge. After that, we looked at the bus design. We use 2 standards. The standards given by the city of Lima, and that is for the frame. And we also looked at the electric bus standard to make sure it was safe and that it could give us the amount of energy required for its route. And we also and then we built the following bus. We used, as I mentioned, BYD, and the model is the Andino K9G 12-meter bus with the 348 kilowatt hours of batteries. It's a high-floored bus. It was important to have a high-floor bus. The reason is because in Lima there are speed bumps, so the bottom of the bus had to be protected from the speed bumps. The bus also was equipped with air conditioning, security cameras, USB ports, and Wi-Fi. As mentioned, we used the data hub from Vericity to collect the data, and the bus started operations in December 13th, 2019 on Route 201. Now, with regards to the electrical charging system, we did simulations of different routes, as mentioned. We visited the depots for each of those bus routes to make sure that the electrical infrastructure that would be set up could be set up in those depots. And then we installed the following charger. It's a 90 kilowatt charger with gun type chargers. This charger can charge the bus from 0 to 100% in 4 hours. What matters with this charger is that we also set up a lockout system to make sure that the bus would only be charged during off hours. For your information, peak hours are from 6 to 11 hours in the evening, which means that the bus would roll this way. 2 trips in the morning starting at 5 a.m. It would run 2 circuits in the morning, would go back to the depot with 65% of its battery load. Then it would recharge for an hour and a half, go back out at 95% on the road, and would be back around 10:30 to start its recharge after 11 o'clock during the off-peak hours, and then would start again at 5 a.m. on its routes. As mentioned, we collected the data on the operation of the bus, and we can monitor these operations in real time. And as you can see so far, the bus has already avoided 77,000 kilograms of CO2, traveled roughly 6,000 kilometers, and we can use the GPS to see where it is located, how fast it's driving, and if the batteries are working properly. As well, as I mentioned, after collecting the data for 6 months, we received the following data. These are data that are promising for the integration of electric buses in the city. On the financial side, the electric bus, taking into account the life cycle cost of over 15 years for a 12-meter bus, is that the electric bus in Lima is 30% cheaper than a diesel bus, 17% cheaper than a CNG bus, and in our analysis, we also acquired the charging infrastructure, and that cost is not only the charging station, but also the transformers and adapting the depot to receive the charging station. Now, the infrastructure allows us to be able to set up to 3 charging stations, so we could have 2 additional chargers and have 2 additional buses in that same garage. In conclusion, the success factors that we can, following the first 6 months of operation of the bus, it's promising for the adoption of the electric bus in urban transit in Lima, and the factors that favor this adoption are as follows. First, the electric buses continue to decrease in price. They are cheaper than the ones we bought. In terms of operations, the electric bus, in terms of costs linked to purchasing electricity, are cheaper than diesel or gas. And that is with only one bus. Now, if we consider a fleet of buses, we could negotiate better rates and it might even be cheaper. The other thing as well is that now with our pilot project, the operator operating the buses has started to be familiar with the maintenance of the bus, which means that if they decide to go with a fleet of electric buses, the maintenance cost would also go down because they will be able to do their own maintenance. And the electric bus is decreasing CO2 and particulate matter emissions in Lima. Now, the key factors of success for the operation of the bus is the development of the pilot project was to have the right partners. What I mean here is that, as mentioned by my colleague Naim, the organizations that participated in the project, the different departments, energy, environment, transportation, as well as the Lima Urban Transit Authority, participated in the project from the outset. And now that they see the bus operating and that they have the data following the collection of data for 6 months, they can conclude that it makes financial sense, as well as allowing the integration of electric transportation in Lima. So this concludes my presentation. So Marie, you have the floor. Thank you, Louis. So we are now into the Q&A and the discussion period. We already have many questions. So you can ask your questions in the chat. So to start, one question for Luis or Naim. Maybe you could start, Louis, because you've just talked about the life cycle analysis and the cost analysis. What is the lifespan of the battery and the impact of replacing the batteries on the profitability of this type of project? With regards to the batteries, what matters when we simulated the routes, we wanted to make sure that the battery would never go down more than 20%. And thanks to the simulations we did, each time the bus goes back to the depot, the bus, I think it was down by 35%. So with that, we are sure that the durability of the bus can be maintained. With regards the guarantees given by the company that supplied the bus, they guaranteed 12 years of operations. Now, we have to make sure to maintain the bus properly, and that's why it's important to simulate the routes that you're going to use and to make sure to have a data hub allowing you to monitor the bus at all times and to be able to monitor the charge on the bus. Well, thank you very much. Now, a question now for Ali. There are a lot of questions on the Moroccan experience, so a practical question. During the promotion of this electric mobility program in Morocco as elsewhere, so Naim and Louis, you can share. So what do you do with the non-electric vehicles when you promote electric vehicles? And we're talking here about a circular economy. Are we generating waste before its time by replacing thermal vehicles with electric vehicles? So is that planned in the Moroccan electric mobility plan? Well, thank you for that question. Well, indeed, that aspect of what we'll do with the thermal vehicles, the internal combustion engines will disappear progressively. It won't happen overnight. That will have an electric fleet and a thermal fleet to dispose of. So our studies look at the environmental impact, and the impact is indeed on the there is an impact of the thermal fleet, and that has been integrated into our study, that replacement aspect. And the evolution of the electric fleet, the evolution of the integration of electric vehicles in the vehicle fleet will take into account the constraint linked to the decision by some manufacturers to switch from thermal to electric. Thank you. Louis or Naeem, would you like to share what's happened in your country? Yes. Well, maybe for Peru, the project, the objective was to give as much information possible to the authorities. Now, the plan that the Urban Transit Authority has in Lima is as follows. First, to replace the fleets of diesel buses. So they're planning on acquiring electric buses to be able to replace the diesel buses. So how will they proceed? They've already drafted the specifications for their electric buses, and they used in part the specifications of the pilot project bus to use our experience. And also, they will use those specifications for the next iteration of electric buses in urban transit in Lima.
So, a question for you now, Ali, and with your experience in Morocco in terms of billing of the recharge, what is expected? What are the studies that are taking place right now in Morocco and the type of billing for the charging points and the variable pricing points depending on the volume, depending on the day, the time of day? What is provided? So yes, in Morocco, we do have a tariff plan, many time indicators. Essentially, there's 3 times the maximum at night and during the day and during the night and during activities. And I think that was provided for. We've done already an exercise on this to examine what are the best structures for fees for the electric energy. Obviously, it would be a tariff with different times. Will be an incentive to go to the night charging, where most of the users charge their vehicles during the night. So obviously, it would be a reduced tariff, a great incentive for all users to charge. Eventually, take into consideration the power that's important. It will certainly be a tariff, a fixed amount to remunerate the needs and power, everything that's in the infrastructure to permit to make it available, this power available, especially to those for the charging stations. It takes a high energy, and so it'd be a tariff with a fixed price and tariffs with the times, depending on the lower or peak times. Do you want to add something on that, Louis? Concerning the project, the pilot project in Lima, we have used the tarification TM2 that was available for electric buses to go in that price range. That wasn't too high. Now, concerning the buses that have more consumption, there will be negotiated tariffs with the companies that will be giving the power. That's what we've seen in Peru at this point. Thank you. I come back on the question of the batteries. the question for taking care of the batteries at the end of life cycle. And for you, Ali, what is provided for in Morocco and above and beyond the vehicles, electric vehicle? We're talking about taking care of the batteries generally in all the projects of electrification and for solar energy as well. Excuse me, you spoke about the batteries. Yes, taking care of the battery after the life cycle. So that is integrated in the study. Once again, for environment's sake, it will propose recommendations for recycling of the batteries. Naeem, I turn to you on this subject and the definition of the conditions of success for a project. According to you, what is the weight? We spoke about the different batteries. What is the weight on the importance of the batteries and the success of these batteries and the service and the impact of the cost of the batteries on the doability and the technicalities of the battery?
20 pounds. So when you keep adding them, it's about 20 pounds kilowatt hour. In terms of the cost, they can range from $200 a kilowatt hour to $500 USD. It really depends on the OEM that you're exercising your purchase agreement with for the vehicle. And what we've found here in North America is the 450 to 500 is the kilowatt hours that most systems are settling on. It still gives them the passenger capacity they need right now. So, but remember that battery density and weight are changing every year. You're seeing a 2% increase in battery density as well as 4% drop in price. So the technology is getting more cheaper as time goes on and it's getting better.
Merci beaucoup. Je passerai maintenant à des questions plus.
So now I'll go back to the questions in terms of running the project with the type of financing that is appropriate for this type of project. Have you speak about it on the importance of having different partners that are involved in this type of project? One specific question on financing. I won't ask you how much this project costs at this time. It's a huge price. But more on the financing that are appropriate to put these type of project in place. So I'll start by you, Ali. In Morocco, what would be the partners that you're looking for in your electrification project? So once again, the study that we have shown shows a part on the financing that can be necessary for this type of electric project. Essentially, the great funders for the financing of this project, the positioning of partnerships, public-private, there as well as the private and the public financing. There can be also the aspect of funds and donations. We know that that's the principal fund for the development of this technology. And so among the different parts for the study to determine between the price of acquisition and the equivalent thermal, there will be a technical study to determine which one is better. And the object of these funding. Thank you, Louis. In the case of Lima, it's interesting that I want to recall in its intervention that you were presenting the role of authorities, local authorities. And so I would like to take this opportunity to put in this dimension in the question in terms of financing, but also as a role that the local authorities have in the projects that have been realized in Lima. Thank you, Maryse. So first of all, I would like to add to this questions that was on the batteries, the partnership, the World Partnership for GSEP, we have developed notes on taking care of these batteries in their second life, and these batteries can be used in other aspects such as renewable energy, solar panels. If you want to have more information on the type of usage and how it can be used, you can go to our webpage and find more information on that question. There's possibilities that to be used afterwards. And now to come back to your question, Maryse, the role of institutions for these pilot projects. Like I've said before, a project pilot is nice to have, but the final objective is to massify or increase, and must have institutions that believe in the technology. And so from the beginning, we've involved the ministries that will permit us to go forward. The Transport Ministry, Ministry of Energy. Why transport? Because Transport Ministry will permit us to improve the rules, to include them in the urban transport. Now the Energy Ministry, to make sure that the infrastructures are in place for the electrical charging, be put in place, and put those chargers in garages of these different operators. And obviously the Environment Ministry, because they will verify the emissions of CO2 that the electric buses will be emitting in the city. And so the urban authorities, transport, that will bring in to show this technology and promote this technology at large in the transport sector. So it's essential to have them from the beginning of the pilot project, to understand the technology and know what is involved in bringing a new technology in and how they can participate. Thank you. And so we only have a few minutes left. And obviously this question that comes back many times is, what is the impact on the electrical network and the mobility? And in that context, a strategic question in terms of priorities of usage of electricity in the countries when the population does not yet have access to the electricity and the usage of domestic use. What is that place of electrification, mobility? And so I'll address myself now with Luis, and then we'll go towards Ariane. And I don't know if the representatives, the director of the United Nations, is still with us. You can intervene if you wish to complete this question. Luis, please. So for the Lima project, it's a country that has been electrified. They have extra electricity, and so with this, they use this electricity to add to transport. Obviously, the mobility transport electrical is more effective than a diesel and gas, because there's a recharge that is possible, and the bus is stopped, and there's not a combustion engine that is working. So it is to be able to use this technology to be able to be more effective in transport and decrease emissions of CO2. That's what I can add on this point. Ali, on your side now, and as Morocco and South African countries, how do you see the priority of the electrical mobility, and it's being reproduced in other countries and that are still not being able to satisfy the electrical needs of their population? Well, for Morocco, we do have the request of power to 4 to 5% increase every year, and it is satisfied at 100% with the means. We have a lot of means production and obviously renewable energy that is increasing from year to year. And those means that are conventional, should we say, to satisfy the requests of the base and the point that has been a problem. If we say, for example, we will see, obviously, after this study, through the recommendations and through the taking into these new technology, the different involvements of all the different partakers, actors in this ecosystem. And normally, the request, for example, if we estimate that there would be for 100,000 vehicles, that represents 4 million, 2.5% for 1,000 vehicles. If we have to recharge, even with a recharge station that is slow, that represent 370 megawatts, it's really important. That is not that negligible. And for 1 million, it becomes 3.5 gigawatts. That represents possibly 30-40% of our electrical system. And so obviously there's efforts to be made that are really important. That's why the United Nations will anticipate these impacts, and it will be done progressively. But there's a question of really anticipating these changes and to integrate them and to provide for the satisfaction of this new usage. And why not? Because it's renewable energy, and it can be very powerful it's a new usage. It will appear and will require a lot of energy, a great need of energy. And I think that if Morocco succeeds in this challenge, it can be a model that will be interesting for other countries to apply. Thank you very much. And so I want to turn to you, Mr. Duval. I want to share to you.
But I want to ask you this question again. In the ability to replicate this type of project in other sub-Saharan African countries, well, that's where I was going. Electrification in transportation, what's beautiful with it is that considering the performance of electric vehicles, whether it's cars, two-wheelers, or whatever, that means that no matter the source of electricity, we have a gain in terms of greenhouse gas emissions. So with a trend that we're seeing throughout the world of decarboning electricity grids, we are encouraging electrification. We are decreasing these factors. So one of the important elements in sub-Saharan Africa, and we discussed it even last week at a conference during New York Climate Week, the access of those vehicles, large cars and motorcycles as well, or community transportation with smaller vehicles, you have to be able to adapt those elements and change your ways of doing things to reformat or re-equip existing vehicles with electric motors, and that's doable. In the intro, I was talking about a partnership, an alliance of working together to electrify transport. It's clearly what we'll need to do with partners like ONEE and large members of GCEP. That's where we want to go. And the challenge of electric mobility is not a challenge of northern countries. It applies to southern countries and Africa as well. It's also something that is relevant and that we can start to work on right now. So I'd like to invite you to continue to go in that direction. And for my part, that would be my response to your question. Well, listen, thank you very much. And we will finish with that intervention. So we've reached the end of our discussions. So we are aware that some questions haven't been answered live, but we'll do some follow-up. Don't worry, we will post the answers to those latent questions on our website So I'd like to warmly thank our experts for the ideas they've changed with us today. Thank you to all of the GCEP team to prepare and organize this webinar. I'd like to finish with the next webinars. From GCEP, we'll have an online webinar October 7th, very soon, on the future of remoting in the electricity, and you can register on the GCEP site. And you've also received a link in the chat. For the IFDD, the next webinar will be October 14th and will deal with the access to private financing for electrification, and will be done in partnership with the ER Club, and registrations will open very soon, and all the information and all the other online webinars are available on the IFDD website. So that's it. So next slide, please. So I simply want to wish you a great day or great evening, and see you soon.